Hi, I'm Miss Van Loan, and in this video, we're going to complete Module 4, Lesson 4, Independent Practice. Remember, I recommend using your math notebook and using your paper the normal way, which is called portrait. Please use a pencil, either number 2 or mechanical, and have an eraser handy. For the purposes of this video, I will be using a blank sheet of white paper, and it will be in the landscape orientation. That is because it works better for the video camera. I'm also going to be using pen because it shows up better on camera. All right, let's get started. Module 4, Lesson 4, Independent Practice. Number 1, which graph shows the best way to find the unit price of top sirloin steak using a graph of weight versus total price? This is the same exact table from the previous work. So we already know the unit price of everything. So let's go ahead and see which graph represents the top sirloin. I went ahead and printed out the graphs because it's easier for me to point with a pen than to try and put the mouse on something and show you. This is an important life skill because someday in the future, if you're going to be dealing with money, which everyone will have to deal with money, whether you like it or not, that's how our society runs, you may want to invest that money in the future for yourself. And you may be looking at different investments. And you may have a piece of paper put in front of you with a graph, and you don't know whether to believe that person or not if you can't read the graph for yourself. So that's just one example I can think of. I'm sure there's others where being able to read a graph and know that you're not being taken advantage of, know that nobody's lying to you about what the graph says, is definitely an important skill. So first, I'm noticing that all of these graphs have total price for the y-axis and weight in ounces on the x-axis. Remember back to our previous independent practice where we were talking about y over x. This makes sense because we have a dollars per ounce. So ounces is on the x-axis and price is on the y-axis. So that totally makes sense. Dollars per ounce, y over x. Y over x. So they're all set up correctly. So our next step is to see that they all start at 0, and then they have another point on here. I don't know where this point is. It's non-existent. It's not on the graph. We'd have to continue this line out and try and figure out where it is. So let's not look at that one for now. Let's just look at the ones where we have a point. And the points are always written. It looks like the other coordinate got cut off, but that's okay. We can see it. It's lined up with 1. Okay? So this point right here is the coordinate 3.45, comma 1. This coordinate is 2, comma 0.58. It's kind of hard to see which one's the decimal, which one's the comma, but if we look at where it's lining up on the y-axis and on the x-axis, we can see what the actual point is. So this is 1, comma 0.29. So we're going to look for that point, rise over run. Rise over run. How far up it went from 0, how far over it went on the x-axis. Remember that? The change in y over the change in x. So let's put that. The y here, and this is where you might mess up, okay? So pay attention to this part. These are x, comma, y. X, comma, y. Coordinates are always written that way. X, comma, y. So you might be tempted to put 2 and then with a line 0.58 underneath it, but you would be doing it wrong. You've got to do y over x. So that's what we're going to do. 0.58 over the x, which is 2, because it went up 0.58 and over 2. Let's look at this one. This one went up 1, and it went over 3.45. This one right here, it went up 0.29, and it went over 1. So if our unit rate for the top sirloin was 29 cents per 1 ounce, ladies and gentlemen, I think we have a winner. We have $0.29 per 1 ounce right there. So you can type into the box on number 1 that graph D shows a rise over run, or a change in Y over a change in X of $0.29 per 1 ounce, and that is the unit rate for top sirloin. Okay, so we are answering the question, it's graph D, and then we're showing how we figured that out, that we found the rise over run, the change in Y over the change in X, how far up it went divided by how far over, and that gave us the unit rate. This is already simplified because there's a 1 at the bottom. If we were doing this one, we'd have to simplify it, so 58 cents divided by 2, well, 25 is half of 50, and another 4 would be $29 per 1. Oh, so maybe B and D? Because this one's definitely not right. And this one, we don't even have a point. This one's like up 2 and over like 8. That's definitely not it either. Okay, so we could actually also say B. I missed that one. Let's add that. Graph B also shows a change in Y over change in X of 0.58 over 2 ounces, which equals $0.29 over 1 ounce. So we have 2 answers here, both D and B. Let's do number 2. Dusty and Carmen were running on the same route. Dusty has a 400-meter head start. Use the graph to estimate Carmen's speed. So, okay, the question just tells us to estimate Carmen's speed. We don't even care about Dusty. Okay, so Carmen is the blue line, and it's starting at 0, 0, and then it's going up. So we're going to have to look very closely to see where it intersects exactly on a corner, because that'll help us estimate a time. So exactly where it crosses these grid lines. Luckily it says estimate, because this point right here looks close, and this point right here looks close, but it's like barely above where the grid lines cross, and this one is like maybe slightly below. I think this one's closer, so let's use this point right here. And of course we're going to be using the origin, because we have to know how far it went up and how far it went over, and that'll give us the meters per minute. So this point right here, we're just going to estimate. We're going to say that it's this across right here, so this is 900 meters. Oh, that's the Y. Let's put the point. So 900 is the Y point. Remember, it's X comma Y. And then on the X, this is 2.5. 2.5 Now we can rewrite that as change in y over change in x, which is how far up we went divided by how far over we went. So we went up 900 meters on the graph, and we went over 2.5 minutes, and then we just need to divide that to get the unit rate. And the unit rate will tell us the speed in meters for every 1 minute, or meters per minute. I'm going to go ahead and write that down here to show my work. Change in y over change in x. And if you missed my previous video, the reason I'm putting the triangle is because triangle is Greek letter delta, which means change. And so in math, we often just use a triangle to represent something as changing. We also use it in science, mostly chemistry, to represent a change, oftentimes in temperature or something like that. Okay, so the change in y, how far up we went, divided by how far over. We went up 900 meters, divided by 2.5 minutes. And let's use our handy dandy calculator. And that is 360 meters per 1 minute. And we can write that as 360 meters per minute, like that too, because the line there means per. Or I guess there's one more. We could write 360 m/min. M is meters, min is minutes. That way we don't confuse them. And you'll see that everywhere. I think that's pretty standard across the mathematic and scientific world, that we use M to represent meters, and then for minutes, it's min rather than just the M. Let's look at number 3. Carmen was running faster than Dusty. At approximately which distance did Carmen catch up to Dusty? So this isn't too bad at all. We don't even need to do any calculations. All we have to do is read the graph. And we're seeing that Carmen is this blue line. And so she's running faster than Dusty. And Dusty got a 400 meter head start, and he's running slower. And we can tell that he's running slower because the line isn't as steep. This is going up faster over time, which means she's running faster over time. And now you may start to notice how in regular speech, we're using mathematical terms. When we say that something is happening over time, we're talking about it in a mathematical way because time is on the x-axis. So since this is going up faster over the same amount of time versus this one, which is going up slower over the same amount of time. So where do they cross? That's it. That'll tell us when she caught up to him and then went farther, faster than he did. Well, that's this point right here where they cross. So we're going to have to estimate. So I'm going to draw this line coming down, and it looks like it's right in between 1.5 and 2, which would be 1 minute and 3/4. So 1 3/4 minutes, because this is 1.5, so 1 3/4, or we could say it as 1.75 if we were going to say it in the way where we put the hours, minutes, seconds, milliseconds. We put a colon in between, and then we use the count of 60 rather than the count of 100. We use a 60-base mathematics. So it would look like this: 1 minute, colon, 45 seconds, because that's 3/4 of a minute. I'm going to use this ruler just to try and get a little bit better sense of where it is. And if this is 600, this line is 700. This looks like it's about 625. It looks like it's maybe 1/4 of the way up there. So I'm going to say that this is about 625. So that means that at 1 minute 45 seconds, Carmen caught up to and passed Dusty at the 625 meter mark. Let's do number 4. AAA Plumbing Company charges customers according to the following formula. Total cost equals the travel fee plus a rate times a time. Below is a graph of the formula. Approximately how much is the hourly rate? This is really common, and if you ever own a business someday, this is the kind of thing you may want to do. For example, a consultant might charge a fee just to show up, and then on top of that, they'll charge a certain dollars per hour of their time. Okay, so 5, 10, 15, 20, 25. It looks like it goes up by 5s, and it looks like it starts at 0 on the x-axis, 20 on the y-axis. So it looks like 0, 20 is that first point there. That means that their fee that they charge just to show up is $20. Then they start charging by the hour. Okay? And we know it's hours because it tells us down here hours. And they're charging in dollars, not some other currency. You know, not Bitcoin yet. All right, so after 1 hour, we're right here. It's not a perfect point. I kind of want to see if there's a perfect point where it lines up with a grid line on the time and a grid line on the dollars, because that'll help us be more exact. So let's look over here. Oh, this one looks like it is perfectly aligned. So it's aligned with 2 hours and this point over here, this line here on the grid. Can you see how this is a perfect point? It's what I like to call a perfect point. I mean, all points are equal, but when I'm looking at a graph, I'm looking for a point that goes through a whole number, or at least a grid line on the graph, so it's easier to figure out what point it is. So this point right here goes through the point 2, comma, and I need to figure out what this is on the y-axis. So remember, we already discovered that it goes up by 5s. So 0, 5, 10, 15, 20, 25. So 50, 55, 60, 65. So this point right here is 65, this line. So this point is 2, 65. So after 2 hours, the person has made $65. That includes the $20 fee just to show up, and then 2 hours worth of work. So let's go back to the information the question gave us, which is that the total cost is equal to the travel fee, which is what I'm calling the fee just to show up, and then the rate multiplied by the time. So what we have here is a total cost of $65. We have the travel fee because we discovered it was $20, plus the rate, that's what we don't know yet. We don't know the rate, so let's just call it X, multiplied by the time, which was 2 hours, times 2 hours. We could have done it for a different point too, and that equation will look a little different. And I do want to show you this just so you know how we're plugging in these numbers. One more example isn't going to hurt. This looks like a perfect point to me. This is at 4.5 hours. 4.5 on the x, and on the y, 100, 105, 110, 115, 120. 120. 4.5 for the time, 120 for the dollars. So the total cost, right, total cost, here I'll do it like this. Actually, total cost was 120 for this point. The travel fee still was $20, the fee just to show up, plus my rate, which I don't know, multiplied by the time, which was 4.5 hours. Okay, so see how we're using the point and then plugging it in to our equation? Good. At this point, we can solve the equation. So let's do that. Remember, I like to think of this with algebra tiles, and we have to use order of operations, PEMDAS. So first I'm going to multiply what's in the parentheses and get rid of the parentheses. So this is still 65 equals 20 plus, and this is 2 times x, or in other words, I have 2 x's. All right, now this looks like your standard 2-step equation, which you've already been doing in the previous module. So if you have 2 x's on this side and 20 ones, right, what are we going to do with those ones? We're going to flip them to the other side, okay? So we take the 20 and we flip it to the other side, and it's minus 20 now. 65 minus 20 is 45, which is equal to the 2x. That's all I have left over here. Now, since I have 2 x's, I want to know what 1 x is. I'm going to divide by 2. So I have x on this side is equal to 45 divided by 2. You could do that in your head, or you can use a calculator. 22.5. So now that we know what x is, we have to go back to thinking about the problem. What does that mean? That's our rate. Okay, so x was the rate, so it's 22.5 is the rate, and remember it's y over x, so that's dollars per hour. $22.5, I've already got the dollar sign, per hour. Oh, I should put a 0 there, $22.50 per hour. Okay? The other way that you could possibly do this, just so that you know there is another way, is to start at 0.20, see how far up you go to get from 20 up to this point here of 65, and then how far over you go. Remember, change in y over change in x is the rate. Normally when we start at 0, it's just whatever the next point is, but we're starting up here at 20. So if we start at 20 and go up to 65, what did we add? What did we go up by? We went up by 45. Do you see that? We started at 20, and then we went up 5, 10, 15, 20, 25, 30, 35, 40, 45. So we went up 45. And then what did we go over? Well, we were at 0 on the x-axis, and we went over 2. So that's still 45 over 2, which is what we got to right there, 45 divided by 2. You can solve this either way, okay? There's no like this way's better or this way's better. It doesn't matter. You can solve it by counting. You can solve it by doing the equation. And I know that there are people out there who prefer the equation, and there are people who prefer the counting. So I'm showing you both because both ways are valid, Both ways get you the right answer, and you can do whatever way works for you and your brain. Okay, so then once we got 45 divided by 2, we would then calculate that. 45 divided by 2 is 2250. Per hour. So we still got the same answer in the end. Okay? That was number 4. Let's do number 5. AAA Plumbing Company charges customers according to the following formula. Below is a graph. How much is the travel fee? Oh, well, we already figured that out on the first one. The travel fee is $20. We need to say why. How do we know that? We know that because at 0 hours, they are already getting charged $20. The customer is already getting charged $20 even though the person hasn't done anything yet. All they did was show up. So that's what we're going to say. The travel fee is $20 because at 0 hours, the price is already $20. Okay? Number 6. A satellite in a circular orbit around the Earth travels at a constant rate. The rate can be found by graphing the distance traveled over time. What is the unit rate or velocity of the satellite shown in the graph? Okay, so here's our graph, and we have the distance is in kilometers and the time is in seconds. So we have kilometers, km, over sec, kilometers per second. And it should be a lowercase k. And we see that we are going to start measuring at 0, 0. So that makes it easy to determine the rate. Let's see if there's any perfect points here. That's just above. Nope, not through any corners. That's just below the corner. Aha, this looks like a perfect point to me. Do you see how the blue line is going right through the corner of this grid line and that grid line? That's what I like to see. So we'll use this point right here. This looks like 1.5 seconds. And this is 7 kilometers. Okay? So if we're doing the kilometers per second, that is 7 kilometers in 1.5 seconds. And I know I can use those exact numbers because we started at 0, 0. So we go up from 0 to 7, and we go over from 0 to 1.5. So that is 7 over 1.5, and that was kilometers and seconds. So now we can calculate that. 7 divided by 1.5 equals 4.6 repeating kilometers per second. Let's go ahead and do number 7. The graph shows the average number of minutes that Leandro has spent running on the treadmill each day over the past several weeks. According to the pattern, for how many minutes did he run on a day during the 3rd week? Let's go ahead and put a line on here. How many minutes did he run on a day during the 3rd week? Okay, 3rd week. This is where we don't have any data. Maybe he did run and he just forgot to record the data, and so he's going to estimate it. But it looks like it's right here at this point. So let's go across here and we'll say about 30, right? It's in between 28 and 32, so about 30. He probably ran about 30 minutes on week 3 according to the pattern. And since you're probably doing this by typing it into the worksheet and you can't actually draw on the graph and show the teacher how you got that, we should explain how we got that. I know because I estimated a point of x comma y, 3 comma 30, a point of 3 comma 30 on a line through the other points. And that pretty much sums up what we did, right? We drew a line through these other points and put in our imaginary point. Okay, that is it for Module 4, Lesson 4. I hope you guys have a great day.